Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos, Ugobela Wemet. And without any further ado, let's look at these questions that we have here. Okay, so question 9 says, a hospital staff member moves away from the ambulance. The siren of the ambulance produces a sound of an unknown frequency. The staff member hears 0.85 times the frequency of the siren as it moves away from the ambulance. The speed of sound in the air is 340 meters per second, right? So 9.1.1 says define a Doppler effect. So we know that the definition will always be there, right? That's how you define it. So you say is the apparent change in frequency of the sound detected by the listener because the sound source and the listener have different velocities relative to the medium of sound propagation. Right. And then we have 9.1.2. It says calculate the velocity of the staff member as it moves away from the ambulance. Right. So as it does what? Moves away from the ambulance. Now we want to start with our formula. FL is equals to V plus minus VL. So remember, always start with the original formula. And then VS times FS, right? Okay. From here on, we can manipulate the formula FL. And then we know if it's moving away, the plus will be down here. And then, so we'll have VL. So because the source is a stationary, remember, hospital staff member moves away from the ambulance, right? So the ambulance at that time is stationary. Then V, so we're just going to have the V here multiplied by Fs. So always remember that if it's moving away, then plus here and then minus there, right? So that's why we see a negative up there. Okay, so what is the frequency of the listener? They said the staff member hears 0.85 times the frequency of the siren. So the siren is the source. So now we can indicate that is 0.85 of the frequency of the source. So that's 0.85 Fs. And then what's V? They told us we must take the speed of sound in air as 340. So we're going to have 340. And then what's the velocity of the listener? Are we told? That's what we are trying to calculate. So calculate the velocity of the staff member, V. Then here we will have 340 and then multiply by VFS here, right? Now to then calculate this, we can get rid of this Fs here by multiplying by both sides by 1 over Fs. So like that, multiplying both sides by 1 over Fs. Then obviously the Fs will cancel out like that. And then we'll be left with 0.85. And then if we cross multiply with this 340, that's 0.85 multiplied by 340 is equals to 340 minus VL, right? So you need to be very quick with your maths because note this, they're not marking much of your maths there. They're just marking your substitution. So if you can just, I will walk you through how they will be rewarding you marks for this one so that you know that you don't waste time with your bunch of maths there. So it's 289 if we multiply here. Then if we take the 340 and transpose it over to the side, or let me just do like this first, 340 minus VL. Then take the negative VL to the side, take this over to that side. So I'm avoiding having to divide by negative. Then VN. So you see, I'm trying to be very, very quick with my maths, and then I don't want to end up having a lot of steps because they're not even marking that maths. So that's 51 meters per second. Now, where are they awarding marks? Where are they awarding marks? So they want to give you a mark for the formula. So whether you start with this one here or that one, so these ones are regarded as the original formulas. And then that's 1. And then number 2, they're going to mark your substitution. So for writing 0.85 fs here, they mark that. And then having to substitute also on this side here. So just everything here, they mark that. Then everything here, whatever that you did with your maths here, they don't care. Now at that point, they're waiting for your final answer. So you want to keep this, whatever that's in here, as minimal as possible. If you can just do it in your calculator and then just show a few steps and then get to the answer, then you are correct. So minimize the time that you take in writing. So 4 marks like that. Okay, so 9.1.3 says, why is the frequency perceived by the listener moving away from the source lower than the actual frequency produced by the siren? Now we know that we have to explain this based on the frequency, the relationship between the frequency and the wavelength, which we know that frequency is inversely proportional to the wavelength, right? So in explaining that, we'll say when the listener moves away from the sound source, the sound waves that reach him have a longer wavelength and thus a lower frequency. And then you can even show that F is inversely proportional to lambda. So you say when the listener moves away from the sound source, the sound waves that reach him have a longer wavelength and thus a lower frequency. According to this relationship, F is inversely proportional to that. So if there is a longer wavelength, there is a lower frequency. And then if there is a lower frequency, obviously the frequency perceived or detected will be lower than the actual frequency produced by the siren. Okay, so that's how you would explain that. Now, 9.1.4 says, if the staff member decided to get inside the ambulance, how will the frequency heard by the staff member compare to that emitted by the ambulance? Right? Only greater than, smaller than, or equal to. Now, if you go back and read Doppler effect, it says the perceived or the apparent change in that frequency is because the sound source and the listener have different velocities relative to the medium of sound propagation. If now the staff member gets inside the ambulance, that means there is no longer any relative velocities there. There is no relative distance between that ambulance and the listener, which is the staff member. So that means now they're inside one object, they're inside that sound source. So there will not be any difference in the frequency. The frequency that will be produced by the siren will be the very same frequency that will be heard by the staff member. So our answer for that one has to be equal to. And the reason for that is because the velocity of the source at that time will be the same as the velocity of the listener. So if there is no difference in the velocities, then that means there is no difference in the frequencies, right? So if Vs is equal to Vl, that means Fs will also be equal to Fl. So note that. Very important for you to note that. Now we have 9.1.5. They say if the frequency of the sound of the source was 190 hertz, what will the magnitude of the frequency registered by the staff member as he was moving away from the ambulance? Okay, what will so how do we do that one? So to calculate that, it would say 9.1.5. We are to calculate the frequency of the listener, remember, 190 hertz. So that requires us to go back here and then say that, remember, they said the staff member hears 0.85 times. He hears 0.85 times the frequency of the siren. So that means if the frequency of the source, we are saying, is 190 hertz, and then we said the frequency of the listener is 0.85, the frequency of the source, then what will be the frequency of the listener? It's simply 0.85 multiplied by what? 190, right? And then when we punch that into our calculator, we find that it's 161.5 hertz. Remember, the 0.85 here is telling you that the frequency heard by the listener is just 85% of the frequency of the source. So the listener hears 85% of the actual frequency that is emitted by the siren. So the 85% is being represented by 161.5 hertz. So understand that. Okay, then 9.2 says, name 2 applications of the Doppler effect in medical science. So we know this one's number 1 is used in the Doppler flow meter to measure the rate of blood flow, and then also it is used in sonar to detect the heartbeat of the fetus. Right, so those are the 2 medical uses of the Doppler effect. So Doppler flow meter to measure the rate of blood flow, and then also to detect the heartbeat of the fetus. Okay, so that's how you could have went about tackling this question for a total of 14 marks. So please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.